Hi everyone, this is Mr. Kuchenmeister here. I wanted to record a video of just going through some of the problems from the Chapter 2 review. Just kind of a recap. This video isn't meant to go through every single problem, but I just wanted to go through some, big ideas from the later half, specifically like stuff from 2.5 and stuff from 2.6. Okay, so I won't be covering everything here. Some of the problems where you have to draw graphs, I may just show you in your calculator real quick again. But if you have any questions after that, make sure you just look on Blackboard. The key is posted. But without further ado, let's go ahead and get into this. So starting off with number one, right? Number one is not something I'm going to spend a lot of time on, at least with this first part, because one, you guys know how to make a histogram. So it shouldn't be too difficult here from that perspective, but I'll show you in your calculator real quick. So if I half and half each screen, I have my calculator up right here. We'll start off with a listed spreadsheet. We're talking about ACT scores here. So I'll put ACT, and then we'll just input the data here. So we have 23, 26, 25, 19, 33, 21, 21, 22, 21, 27, 19, 25, 18, 23, 22, 30, 27, 27, 23, 16, 21, 19, 20, 30, 22. And the problem does say we have 25 members, and I have 25 numbers. Very good. Just scrolling up, making sure that we have everything. Okay, I don't see any typos. All right, so one thing I'm going to do right away is I'm going to sort it. So make sure you got the whole cell highlight or the whole column. We're going to go menu, actions, sort. We want to sort them ascending. All right, because that's going to come in handy in a little bit here. All right, now to make your histogram, add a page. We want data and statistics. Add our variable to the x-axis. Control menu in the white space. Histogram. And obviously, you guys know that this is not a good histogram. So we need to tidy up our bin width, and we need to tidy up our width. Our first number is 16, so that's what we're going to set the alignment to. So bin settings equal bin width. The alignment should be 19. Oh, I'm sorry. There is a 15 here, I believe. Hold up. I'll just double check the data here. Cancel that. Oh, I'm sorry, there's a 16. The alignment should be something like 16. And let's just start off. Let's start off with a bin with what that does. Yeah, that's a little better. Okay, let's do something here. Again, remember when you're making this, let's do the alignment at 15, see if that gives us any better results. Yeah, all right, I like that. So again, remember, just play around with it. Make sure you zoom data, and there's your histogram, right? So, like I said, not going to spend a whole lot of time making this. You guys all can see older ed puzzles, and we can go from there. All right, what I do want to talk about, though, is 1B, okay? So, find the position of the 95 percentile, all right? So there'll be a question like this on your test. So what we're going to do here is we need to find the position first, okay? So that's where we're going to use this P to the K formula. So here we're going to use, I'll come down here. So we got P to the K equals P to the 95th, P sub 95. So that's going to be, N is 25 here because we have 25 test scores times 95. And we're going to divide that result by 100. All right, so if I put that in my calculator here, 25 times 9, 25, that's going to equal approximately 23.579. So we would automatically round that up to the 24th spot. So the position is the 24th number in the list, which if I come back to my calculator and I go to the 24th spot in my sorted list, I have that the 24th spot is a score of 30. Okay, so make sure you do know how to do that. It's going to be important. Okay, our 5-number summary. All right, we can find that by just simply going to open up a calculator page here, and we're going to go menu 611 for one variable stats. Choose our list, and then voila, we start at the minimum all the way to the max. There is our 5-number summary. So our minimum is 16. Our quartile 1 is 20.5. Our median, which is our X squiggly, as I always call it, is 22. Our Q3 is 26.5. And our max is 33. Which means our IQR, which is quarter 3 minus quarter 1, is 26.5 minus 20.5, which is a grand total of 6 points. So 50% of the data lies within 6 points of itself. Okay. Now, again, for your what would be considered an outlier here. So remember, the formulas here for this is low equals quarter 1 minus 1.5 times the IQR. So for this, we're going to go quarter 1 is 20.5 minus 1.5 times the IQR, which is 6, which turns into, if you put that in your calculator, is 11.5. So anything below a score of 11.5 is an outlier. For the high, we're going to do the same thing, but now we're going to do quarter 3 plus 1.5 times the IQR, which would be 26.5 plus 1.5 times 6, and that's going to give us a score of 35.5. So anything above a 35.5, which if you know anything about ACT scores, the only score possible above a 35.5 is a 36. So you would have to get a grand perfect on the ACT, which is doable. It's been done, but extremely hard. All right, now we're moving on to number 2. All right, so number 2, the convenience score, track of paying customers that it had during the noon hour each day of 100. The mean number of customers was 95, and the standard deviation was 12. Using mean, standard deviation, and the empirical rule, apply the normal model to the number of paying customers. Okay, so if we're applying the normal model here, remember, a normal model is considered N, where we have the first number being our mean and the second number being our standard deviation. So if I take a look at this and we go, this one's going to be a normal model of 95, 12, right? So that means down here on this graph with my z-scores, I'm going to have, here's my z's, so 0, 1, 2, 3 standard deviations, -1, -2, -3 standard deviations. Applying the normal model, what we would do is we are going to put our mean right under 95, because we know for a normal model, 95 lines up with 0, and then we just add 1 standard deviation, which is we're adding 12, so 107. Add another 12, 119. Add another 12, 131. Okay. Then we go. Now we subtract, so that's going to be 83, 71, and 59. Okay. Okay. So that's the normal model applied. Okay. Now for the empirical rule, all right. Remember, the empirical rule states that, hey, okay, between 1 standard deviation, so -1 and 1, so that would be between 83 and 107. We know 68% of the data lies here. Between 2 standard deviations, we know 95% of the data lives here, right? And then finally, from 3 standard deviations, we know 99.7 of the data lives here. Okay, I would like you to take that one step further. Okay. So what I mean by that is I would like you to break this down even further, okay? And there was a slide in the puzzle, so I'm going to show you quickly how to do it here, okay? First thing, you have to remember that the normal curve is symmetrical, okay? So we start with, I'll just come over here and write the empirical rule, all right? So between 1 standard deviation is 68%, which means since it's symmetrical, if I divide 68.2, that means 34% of the data is between -1 and 0 and 0 and 1. Now for 2, we have 95% of the data. To get these guys between -2 and -1 and 1 and 2 standard deviations, we have to take into consideration we already accounted for 68% of the data. So what we need to do is I'm going to do 95 minus 68. I'll come over here, 95 minus 68, and that's going to give us a total of 27. There's 27% of the data between -2 and -1 and 1 and 2. So I got to divide that by 2, and I'm going to get 13.5. All right. We have 13.5% between -2 and -1, 13.5% between 1 and 2. Now we do a similar process for the third standard deviation. So we know between 3 standard deviations, that is 99.7. But once again, I have already accounted for 95%. So we're going to do 99.7% minus 95%. That's going to give us 4.7, which means if I divide that by 2, I'll get 2.35%. Between -2.35 right here and 2.35 right here. You can write above the line, it helps. Okay, now the last thing I always like to account for, and I mentioned this in class the other day, but everyone forgets about these tails, all right? There is only 99.7% of the data under this normal curve between -3 and 3, but we know total area under a curve is 100. We have to account where the rest of that 0.3 go. Well, it's actually beyond the tails, beyond 3 and beyond -3. So we just know, hey, if there's 99.7% of the data inside, there is 0.3% left on the outside. Divide that by 2 to get 0.115. On the tails, 0.15%. No matter what, okay, applying the normal model of the data, that's really down here and right here, okay? These numbers will never change. This is your empirical rule, okay? Spoiler alert, this will be a question, not only on this test, but in future tests, all right? But now what I can do is, if we assume the number of paying customers are normally distributed, approximately what percentage of all such days will fall between 119 and 71? Well, 71 is right here. 119, that's between 2 standard deviations, so I'm going to add all 13.5 to 34, 34, 13.5. Or you can just go, hey, that's between -2 and 2. That is this guy, 95% of the data. Okay? You can see above here. All right, lastly, a z-score calculation. I know there were 2 parts there. I only snipped one of them. Compute z-score for the corresponding values of x. All right, so that's using the z-score equals the value minus the mean all over the standard deviation. So the formula for here would be 40. So we're going to go z equals 40 minus the mean 60 divided by the standard deviation of 4, which would equal -20 divided by 4, which would be a z-score of -5, which is, as we'll soon learn in probability, that is that's a pretty nuts z-score. It's -5 standard deviations below the mean, below x bar. All right, so just make sure you know how to use the z-score formula. Okay, moving on. This is calculating standard deviation. All right, I'm not going to do this one because I think, again, we practiced a quiz review on this. Just friendly reminder, right? This number should always be 0. Okay, this number is not the number that goes here. All right, it is just the top number in the formula, sum of deviations squared. Okay, whatever this number is, you have to divide by n-1 to get your variance. Another thing here, watch your labels. Okay, if you have any questions on this one, email me. Okay, remember, why does the sum of our deviations go up to 0? Because remember, just remember, all positive deviations cancel with negative deviations. Okay. All right, z-scores. All right, so who did better on exams? Chris scored a 75 on Mrs. Pesick's exam with a mean and standard deviation was 65 and 4.8. But then on a different exam, Angela scored an 84, mean and standard deviation was 78 and 7.6. How do you do this? Well, you actually calculate 2 z-scores, all right? So the reasons why is because we're dealing with different means and standard deviation. So we want to see how well relatively did Chris and Angela. So let's start with Chris. Z-score for Chris. He scored a 75. And again, the whole thing, we're using this formula. X minus X bar divided by standard deviation, right? We're going to do 75 minus the mean, which was 65, and we're going to divide it by 4.6. If you put that in your calculator, you're going to get a standard score of 2.174 standard deviations above X bar. And then for Angelo, we're going to do, he scored an 84, and I'm going to pause it for afternoon announcements. Okay, so we are calculating Angelo's Z-score, and I don't know why my cursor is not working. There it goes. Maybe. All right, so we have 84 minus 78, and we're going to divide that by 7.6. And once we accomplish that, let me just quickly put it into a calculator. We get 0.789 standard deviations above X bar. Now, I know you're probably thinking about, well, wait a minute, an 84 is better than a 75, so you would think Angela did better. But when we compare it to the rest of the class, right, on average, Chris did better. So Chris did better because compared to the average, he had a higher score. Obviously, if it was the same class, the same test, right, we don't need to do all of this because, you know, it's just the higher score wins. But we're trying to compare average. We're trying to compare scores compared to an average, right? As we know, this first class, this is PESIX exam, the average was a 65, so it's a lot better. All right, moving on. Okay. And I guess we can go ahead and do this one. At one university, the Z-scores are given at each semester at triple GPAs. We want to calculate GPAs based off the Z-score, okay? So I'll just do one of these. This is just simple algebra. We're given the Z-score now. We want to calculate the score. So we're told they're normally distributed, and then the mean and standard deviation is, so 2.7 is our mean, 0.5 is our standard deviation. So if I want to calculate a GPA for a Z-score of 0.7, once again, using this, Z equals X minus X bar over standard deviation. So I have 0.7 equals X minus the mean, which is 2.7, all over 0.5. And now we multiply both sides by 0.5. It cancels. We're left with X minus 27, or 2.7 equals, what we're going to get is 0. Let me math because I can't think out loud. 0.5 times 0.7, and we get 0.35. Now we're going to add 2.7 to both sides, and we get 3.05. Well, that's the Z-score is 3.05. Or I'm sorry, the GPA is 3.05. All right, and that makes sense, right? Because if I think about it, right, a Z-score of 0.7 means 0.7 standard deviations above the mean. So it should be just barely above 2.7, and just barely above half a, just a little over half a standard deviation. So good. And we move on, okay? Lastly here, right, you know, we're just based off the shape here, what can we assume? So just remember that this is just good facts to have. This is approximately a normal, right? So we know here that X bar should roughly equal our median, okay? Here we have skewed left, where because of these data points here, our mean is going to be less than our median, so less than, and then lastly, a skewed right. Our mean will be dragged out to the right, so it will be greater than the median. So that being said, let me know if you have any questions. Check the key for the rest, and we'll see you guys in next class where we will test. All right, take care.